Okay, we're going to have some additional problems here that we're going to work with. One of the things that I want you to remember is that 1 becquerel is equal to 1 decay per second, or dBs. That's how it's commonly referred to as. Cobalt-60 has a decay constant given here in years in the denominator. So find the activity in megabecquerel of a sample containing 10 to the 15th atoms. So the activity is going to be equal to lambda times the number of atoms. We know what lambda is because that's given to us, the decay constant. We know how many atoms we have. And here we know how many seconds there are in a year. By doing all of these computations, we can come up with 4.2 times 10 to the 6th atoms per second, or 4.2 times 10 to the 6th becquerel. If we see a 10 to the 6th, we can replace that with a capital M, and so that becomes 4.2 megabecquerel. So radioactivity of a sample per unit mass is the specific activity of a sample. It's a way for us to be able to compare radioactivity while taking mass out of the equation, as it were. So what is the specific activity of that sample in megabecquerel per gram? So the gram atomic mass of cobalt-60 is 59.9338. So the sample mass here, 10 to the 15th atoms, and we know how many grams there are in number of gram atomic mass. If we take that result and we divide it by 6.023 times 10 to the 23rd atoms per grams atomic mass, that cancels, this cancels, and that leaves us with just the grams here. So we get 9.95 times 10 to the 8th grams. Specific activity, that's the sample mass. The specific activity is going to be 4.2 megabecquerels, which we found up here, dividing it by the mass, because when we do that, that gives us the specific activity. Again, this is something for a gram of substance that we can compare along several different substances. Problem number 2, what are the half-life and average life of the sample of cobalt-60 described in sample 1? Well, the half-life, if we know what lambda is just 0.693 divided by lambda, and that's what it is in years. The average life is going to be 1.44 times the half-life. And as you do the computations, you come up with 7.57 years. The physical half-life of 131 iodide is 8 days. A sample of 131 has a mass of 100 micrograms. How many iodide 131 atoms are present in the sample? So the number of atoms is going to be equal to the number of grams, which we have here, times the number of atoms per gram atomic mass. So we know what that is. We have our number of atoms per gram atomic mass. We know how many that is. We know the number of grams here, and then we're going to divide that by the number of grams per gram atomic mass. So we take the gram atomic mass, those two cancel, the grams cancel, and we're left with a number of atoms. So how many iodide 131 atoms remain after 20 days? We can use our count equation here for the amount. So we have the original amount, how much we end up with, and then we can determine from here exactly how many atoms we're going to have remaining. So this we could replace with lambda, but doesn't look like we've done that. It looks like we just put in 0.693 divided by 8 days, which is the half-life here of iodide 131. And we know we're going to have this for 20 days. So when you do the computations here, you come up with 8.1 times 10 to the 16th atoms. So what is the activity of the sample? The activity is going to be related to lambda times the number that we have. So we're going to have lambda equal to this. We know what the number is because we just computed that up here. We go through, we do the computations to change seconds or days into seconds. And when we do that, we end up with 0.693, and rather than 8 days, it's 691,200 seconds. So we know what lambda is in per seconds. We know what the number of atoms are, so we know what the activity is because it's that number of atoms per second that are decaying. So what is the specific activity of this? The specific activity, again, we take the activity that we have here, we divide it by the number of grams that we have, which ends up being 0.1, and we come up with this. So what activity should be ordered at 8 a.m. Monday to provide an activity of 8.2 times 10 to the 4th megabecquerel at 8 a.m. on the following Friday? So the number of elapsed days is 4 days. We know what the original activity is, or we know what the activity is, or what it needs to be here on that Friday. Sorry, my bad. We just need to know what activity we need to start with. We know what lambda is, or at least can compute it. We know how long that needs to be, which is 4 days. Come up with this. Take both sides, divide it by this. So we have to order an activity of this amount in order to make sure that we have this amount of activity on that Friday. So this activity gets ordered on the Monday in order for us to have this activity on that Friday.